Bismillahirrahmanirrahim. This is numerical problem number 7 to unit number 14, current electricity, physics 10, National Book Foundation. So question number 7 says two resistors of 4 kilo ohm and 6 kilo ohm are connected in parallel. A 10-volt battery is connected across its ends. Find the values of the following quantities. There are three different quantities that have to be calculated. Number one is equivalent resistance of the parallel combination. Now, this is the parallel combination of 6 kilo ohm and 4 kilo ohm shown here with a 10-volt battery connected across its ends. This circuit can also be drawn like the one shown here, 4 kilo ohm resistor, 6 kilo ohm resistor, both connected with a battery like the one shown here. I feel this one to be more clear for the students, so I'll keep this one here. And however, I have shown this one. There is no problem absolutely with this circuit as well. So you can even draw this one for your questions to do. So the equivalent resistance of a parallel combination is given as 1 over R equivalent is equal to 1 over R1 plus 1 over R2. Substitute the values of 4 kilo ohm and 6 kilo ohm. I'm not writing the word kilos here since they are both same units, kilo ohms. So we'll be considering them as kilo ohms. So take the LCM of 6 and 4, that is 12. Now solving this, 3 plus 2 makes it 5 over 12. This is 1 over R equivalent is equal to 5 over 12 ohms. So R equivalent is equal to 12 over 5, which is 2.4 kilo ohms. As I said earlier, these quantities are in kilo ohms, so we will write kilo ohms with the result. Here I want to give you a tip. Dividing this 12 number with 5. If you're dividing any number with 5, there is a tip how to do it mentally. Just double the numerator, the number above 5. Double it. Like doubling 12 will make it 24. Since there is only one digit in the denominator, that is number 5, put a decimal after one digit. So that is doubling 12 means 24. Decimal after one number, that makes it 2.4 kilo ohms. So for that matter, any number divided by 5, just double the number, put a decimal after one digit. You will get the answer. Now, the second part of the question is current passing through each of the resistor. Now, since the circuit shows a combination of parallel resistors, using Ohm's law, the voltage across both the resistor is same. Remember, in a parallel combination, the voltage across the resistors in parallel combination is same, that is 10 volt across this resistor R1 as well as 10 volt across this resistor R2. So using Ohm's law, I1 is equal to V over R1. V is same as 10 volt. Put V is equal to 10, R1 is equal to 4 kilo ohm, that means 4 into 10 power 3 to make it kilo ohms. So I1 becomes 2.5, this 10 divided by 4 makes it 2.5. This 10 goes in the numerator with a negative power to make it 10 power minus 3 ampere, or to simply write as I1, the current passing through R1 is equal to 2.5 milliamperes. This 10 power 3 represents milliamperes. Similarly, I2, the current passing through this 6 kilo ohm resistors, again put V is equal to 10, R2 is equal to 6 into 10 power 3, that means 6 kilo ohms. Calculating 10 over 6 makes it 1.67. and this again 10 power 3 in the denominator once goes up, it makes it 10 power minus 3 ampere, or simply write it as I2 is equal to 1.67 milliamperes. Now the third part is potential difference across each of the resistors. Now, as I stated earlier as well, the potential difference across resistors in parallel is always same as that supplied by the battery. So in a parallel combination, voltage across each of the resistor is same as that of the voltage source or the battery. That means 10 volt. So voltage across these two resistors will be 10 volts. Now comes the second part of the question, and that says, now these resistors are connected in series. Again a 10 volt battery connected across its ends, and find the value of the same three quantities. One is equivalent resistance of the series combination. The equivalent resistance of the series combination is given as, this is the series combination, 4 kilo ohm and 6 kilo ohm. So first we calculate R equivalent, that is equivalent resistance of this series combination, which is given as R1 plus R2. So R equivalent is equal to 4 plus 6, that makes it 10 kilo ohms. Now, in a series combination of the resistors, there is only one path for the current to flow. That means same current passes through all the resistors or devices. That means this is current I which passes through this battery and then goes through the two resistors. Using Ohm's law, I is equal to V over R equivalent. R equivalent we calculated in the previous step. R equivalent calculated in the previous step is 10 kilo ohms. So I is equal to 10 divided by 10 into 10 power 3. 10 is the voltage V, and this 10 kilo ohm is the R equivalent. Making this calculation makes it I is equal to 1 milliampere. Okay, this 10 cancels with this. Only 10 power 3 remains, which is written as 10 power minus 3 ampere or 1 milliampere. Now the next part is potential difference across each of the resistors. In order to calculate potential difference which goes through R1 and R2, this can be calculated in a series combination. Current through each of the resistors is same, since there is only same current I, that is 1 milliampere we calculated in the previous step. So use Ohm's law to calculate the potential difference across each resistor as, so it is potential difference across R1. This is the R1 which is 4 kilo ohm. So V1 is equal to IR1. This is 1 milliampere current I. This is 4 kilo ohms R1. Now this 10 power 3 and this 10 power 3, they cancel each other, and result comes V1. Voltage or potential difference across this device is 4 volts. Similarly, potential difference across R2, this is the second resistor with 6 kilo ohm. Again, V2 is equal to IR2, 1 into 10 power minus 3, that is 1 milliampere current passing through 6 kilo ohms resistor. This again 10 power 3 and this 10 power minus 3, they cancel out, and which results in V1 is equal to 6 volt. Remember, this 4 volt plus 6 volt make it 10 volt. That is the battery voltage supplied to the circuit.